Martin and I are recording a video. What problem are we doing, Martin?
11.8.
What page?
373.
373. Please read the problem to us.
If a solution is made by dissolving 2.30 grams of Mg open parentheses OH close parentheses 2 into 25.0 grams of acetic acid C2H4O2, what is the freezing point? Kf of acetic acid is 3.90 degrees Celsius over molarity. Freezing point of pure acetic acid is 16.6 degrees Celsius.
Wait, sorry. Oh, the freezing point. Thank you. 6 degrees Celsius.
16.6 degrees Celsius.
Okay. So when we calculate the delta T, okay, we're going to subtract, or we're going to add the delta T. It'll probably be a negative number, and we'll find out what the new freezing point will be, right? So we need to figure out. So what's the first thing we need to know?
How about ions?
Well, let's think of our equation. What's the equation we're trying to set up? Delta T
equals negative I times molarity times K underscore A F.
Okay, so molality, not molarity, times the Kf times the negative I. What is the negative I? It's the number of molecules or ions that we have when the substance dissolves. So here we have MgOH2. So what does that tell us about the number of ions that are going to be present when it dissolves?
There's going to be 3 of them.
Yeah. So the negative number is going to be negative 3, right?
Yeah.
Okay. So what is the Kf? We know that as well.
Yeah.
It's 3.9 degrees C per
3.90
degrees C per molality. So how are we going to figure out the molality? The molality is the number of moles of solute per number of kilograms of solvent. So we don't know the number of moles of solute. We do know the number of grams. So we can use the conversion factor to figure out how many moles we have. Let's figure out MgOH, how many grams per mole we have.
Okay, magnesium is 24.3.
Okay, and we have 2 oxygens. So that's 16.0 times 2 is 32.0. And hydrogen is 1.01. So we have 2 of those, 2.02, right?
Yeah.
6, 8, 5. So 58.32, right?
Yeah.
Grams per mole, or 1 mole per 58.32 grams. We're going to multiply 2.30 grams times 1 mole per 58. Excuse me. Just report this is 58.3. We're going to ignore that 2 because we don't have enough precision. So go to hundredths place, 58.3 grams. Okay, so we're going to divide 2.30 by 58.3. And then we'll know how many moles we have. Martin is performing that operation in the calculator. Yes.
It's 0.0394511.
0.0, sorry.
39451114.
Stop. So we have 3 3s. So we want 1, 2, 3. So we're going to say 0.0395 moles. Okay, so 2.30 grams of magnesium hydroxide is equal to 0.0395 moles, right?
Yes.
So now we know the number of moles of solute. Let's convert this number of grams into kilograms, which is what we need. So we're going to divide this by 1,000. 1, 2, 3. So we're going to say the molality is going to be 0.0395 divided by 0.025. It's going to be a little more than 1.
1.58.
Is that exact? There's no
Yeah.
more? Okay, and here we have, this had 3 significant digits, the grams over here, the 25 grams. So we can keep 3. And so that's good because that's what we ended up with. So now we put that into the equation. Back over here, we've got -3 times 3.90 degrees Celsius per molality times 1.58 molality. Molality cancels. So somewhere around -15 or something degrees.
-20, actually.
Yeah?
-18.48, but 486.
Can I just check your calculation? Can I just see it? Thank you so much. I'm not disagreeing with you. I always check my own. Okay. So -1.8486. So here we have 3. Here we have 3. We don't need to worry about the significant digits in the ions. That's an exact number, so we're not worrying about the sig digs. So we want 3 here, so we're going to say -18.5. Right, we're going to round up. Okay, so now we're going to say that the change in temperature, we're not done yet.
Well, we know the change in temperature is.
No. So this isn't, the freezing point of water is 0 degrees Celsius. So in the previous problem, we didn't have to perform any sort of subtraction.
Okay.
Comprende?
Yeah.
So now what are we going to do? This is the change in temperature. It's going to change this many degrees. What's the normal freezing point?
0 degrees.
No, it's not.
Oh.
The freezing point of pure acetic acid is 16.6 degrees. I wrote that here. So what are we going to do?
We subtract 18.5 from 16.
We're actually going to add -18.5.
Okay, so we're going to
to
subtract.
the delta T.
Yes.
I mean, to the freezing point. So look, we add the delta T to the freezing point.
Okay. -1.9.
-1.9 what?
Celsius.
Degrees Celsius. So the new freezing point is -1.9 degrees Celsius. Okay? Does this make sense to you?
Yes.
So acetic acid without this solute dissolved in it will have a freezing point of 16.6 degrees Celsius. But when you add this solute, the freezing point is lowered, 18.5 degrees Celsius. And so you end up with a new freezing point of -1.9 degrees Celsius. Okay. That's it for problem 11.8. Thank you.